All right, here's our first video. We're going to talk about solving equations, and we're also going to talk about simplifying expressions and just some basic algebra skills. So just some basic definitions here. Equations, if you don't know this, equations are things that have equal signs. So there's something where you can solve for x. So for an example, if you had an equation, you might get to the end and have an answer that would say something like x equals 3. Or just a value for x. And to solve equations, we use opposites operations. So what I mean by that is addition and subtraction, they undo each other. To undo multiplication, and here I'll actually write that a different way. Addition and subtraction undo each other. Multiplication and division are going to undo each other. Some other operations, you're not going to see them today, but we might see them later on. Squared and square root, they undo each other. So that's what we mean by opposite operations. All right, and then expressions, you can only simplify. So you can't get down to x equals something. You may get down to an answer that's like 2x plus 1, and that's all you can do. You can't combine 2x and 1 because one of them has a variable and the other one does not. You notice an expression because there is no equal sign, which is the same reason you can't get an answer, because if there isn't an equal sign to begin with, how would you be allowed to put one for an answer? And we're going to use specifically the distributive property, which we're going to see here in a second, and combining like terms, which we talked about there, but we're going to see there in a minute also. Okay, so here's two examples for expressions. I will let you know in this video there are going to be a lot of examples, but they're going to be very short. I did as few as I could possibly do, but you need to make sure you get every single one of them written down in your notes. All right, so example A here for expressions. Distributive property we know to do when we see parentheses here, and all distributive property tells us to do is to multiply whatever number we have in the front. So we're going to do 2 times 3x. That's going to give us 6x. 2 times, when I look at this number, you need to start seeing this as -5, not -5. So 2 times -5 there is going to be -10 plus 4x squared. So now that we've distributed, we want to combine like terms. And some people think, oh, well, I'm also supposed to do something with that squared. That squared is only on the x. It is not on the 4, so you can't do anything with this number. It just stays like that. You may also try to think, well, x, there's an x here and an x there, but if you have just a regular x and an x squared, think about those as being two very different things, so you can't put them together. So in all reality, this right here is our final answer. That's all I can do there. B, one thing you're going to notice distributive property, sometimes people try right here, they try to do that subtraction first and make that a 3. You cannot do that. Think about order of operations, right? If we do order of operations, we have PEMDAS, which tells me I have to do parentheses before I can add or subtract, which means I have to take care of that 5 first. Okay, so let's do that. So if I distribute my -5, remember, just like we learned today, the signs are attached to the numbers. My 8's going to drop down, 8. When I distribute -5, I've got -5 times 1 is -5. -5 times -9 is positive 45x. And now, the only terms here that are like terms that I can combine are my two numbers. The 45 has an x with it, so it could only go with something else that has an x. So my final answer now is going to be 3 plus 45x. All right, to keep us from getting bored, I've included some kind of the trickier versions of solving equations. So in example A here, x is stuck on the top, which means I'm going to have to get rid of this -5 down here at the bottom. Well, this whole fraction bar means division. So to undo division, I'm going to have to multiply by -5. That's the only thing that's going to cancel out. So if I do it to one side, notice if I did it to the left side, I had to do it to the right. So on the left, I did that so that those things would cancel, and I'm left with -4 plus x. And then on the right side, I just worked that out. -5 times 0, well, that is 0. All right, now I want to get x by itself, and I have to use opposite operations, so I have to get rid of this -4 out here. Well, to get rid of that -4, I'm going to use a +4. And if I do it to one side, I've got to do it to the other. So I've got x equals +4. Remember, just from your early algebra days, you could always check that by plugging in. So mentally, I could plug 4 back in here. -4 plus 4 is 0. 0 divided by anything is going to be 0, so I know that that's correct. All right, example B. Again, we have parentheses, so we're going to need to start with distributing. Remember, always start with parentheses if you have them. So that's going to give me, on the left side, 84 stays the same. I'm going to get +24 minus 4x. Make sure you know where I'm getting those numbers from. That's just multiplication. And then I need to get x by itself, and I've got two things with the x this time. A 24 and a -4, and the 24 is what I've got to get rid of first. You got to think about it like the -4 is attached, so it's going to be a little more difficult to get rid of. So that this is a +24, so to undo that, I've got to use -24 on both sides. Those cancel. Even without a calculator, you should be able to see that that's 60, -4x. And now, when two things are bumped up against each other, you should remember that that means multiplication. That's -4 times x. So to undo multiplication, we're going to divide. So we're going to divide both sides by -4. And I'm going to be left with x equals -15. I know that because I think about a clock, but if you needed to, you could count up or divide another way. Just make sure you can do most of this multiplication, division, addition, subtraction without a calculator. All right, some people get freaked out because you've got a fraction here, but it's really not as bad as you might think. So on this, again, these are attached, so they're the last thing we can deal with. That 4 is going to be a little more pesky to deal with. Think about it as it's attached to the b, and it's a little bit harder to get rid of. So instead, I'm going to get rid of this -3 first, and to do that, I'm going to add 3. That's going to give me 5 equals b divided by 4. And I just said that. That's a fraction bar, which means division, and we already talked about undoing division. We're going to multiply both sides. Notice that when I multiply, I don't use opposite signs. All right, so those cancel, and I'm left with 20 equals b. You know you're finished with an equation because you get down to the variable completely by itself. All right, for a second, these are going to seem like they're getting easier. There's nothing to distribute here, and these are not on opposite sides. They're on the same side of the equation, so I can't use opposite operations. I'm just going to combine them because they're on the same side of the equation. That may be something you need to write down. So when you do that, you're going to get 7x equals 0. And now the only thing keeping x from being by itself is the 7. And to undo that, that's multiplication. So to undo, I'm going to divide by 7. Let me switch colors. Divide by 7. And I'm going to cancel, and that's going to leave me with x equals 0 divided by 7. Doesn't matter how I cut 0 apart, it's still going to be 0. So x equals 0. All right, example E here. Again, getting back to parentheses, so we're going to need to distribute. So the left side stays the same. 2 times 4 is 8x. 2 times 3 is plus 6. Now I have x's on both sides, so I just need to get my x terms together. And to do that, I'm going to subtract. And you might notice that this is going to do something kind of weird because 8x minus 8x cancels, and 8x minus 8x cancels. Well, I still need something on the left side of the equal sign, and if there's nothing over there in math, nothing is 0. And the other side is 6. And probably a few things should jump out at you. One, now I don't have an x anymore. We said the answer to equations is x equals something, and I don't even have an x. So how could I say that there's an answer? So then we're just going to evaluate, is this true or not? So the two notes that I would maybe take before we even answer that is because there is no x, this is going to be a special case. because there's no x left in the equation. And then we want to ask ourselves, does 0 equal 6? No, 0 never equals 6. So because this is a false statement, because this is false, what we're going to write as our answer is that there is no solution. So your answer here is no solution, because that's a false statement. 0 does not equal 6, and it never does. All right, again, we're going to distribute. I have 7 distributing. Notice that it only distributes to what's inside the parentheses, not the -8. I also have a -4 distributing on the other side. So if you will pause and go ahead and try that, let's check and make sure you can do that step correctly. All right, check your signs. Make sure you did all your signs correctly. Now we need to combine like terms. So first, I'm just going to look at my left side and see, are there any pieces that I can put together? And in fact, I can put 56 and -8 together. I can combine those. So I'm going to simplify again. I've got -28x plus 48 equals -4 plus 32x. I need to get my x's on the same side. I tend to look at my 2x terms. So I've got -28 and positive 32, and I move the smallest one. So -28 is smaller, so I'm going to add 28x to both sides. All right, that's going to leave me with 48 equals -4 plus 60x. And then I need my numbers on the same side. So to do that, I'm going to add 4 to both sides, which is going to give me 52 equals 60x. And then last step, x is with the 60 that's being multiplied. So to undo that, I'm going to divide by 60. And that's going to give me, now you may notice 52 doesn't divide by 60. We're kind of getting some big numbers here. So the first thing I want us to do is just cancel what we've got and write down what our answer is right now. So as of right now, this reads x equals 52 over 60. I'm just going to leave it as a fraction because I'm not using a calculator, so I can't divide it into a decimal, and I don't want to. The only thing that we can do now is maybe divide those or simplify them so that I have a smaller fraction. And you may notice that both of these numbers divide by 4. If you don't notice that, you can divide them by 2 first. But I know that they're both going to divide by 4, which means my final answer is going to be x equals 13 over 15. And I can't simplify that anymore, so I'm just going to leave that fraction as my answer, 13 over 15. Fractions are okay in algebra, so don't freak out if you start getting fraction answers. All right, last one, thank goodness. Okay, I can't do anything on the left side. These can't be combined or anything, so I need to distribute on the right. Be careful because there is a number that's distributing right here that you don't actually see, and that number is -1. So -1 is going to distribute here. So pause and take a minute to do the distributive property for yourself. All right, now let's check and make sure we got our signs right. On this right side, there's still some more I can do to simplify. So I'm going to combine like terms, which are my 4x and my -5x. So to do that, I've got 4 minus x equals -x, or -1x if you want to say, plus 4. I will tell you there were some other steps that you could have taken first. What I'm showing you is not the only way to do it. It's just the way that I would do this. Now I want to get my x's together. So I'm going to add x. Remember if they both cancel, that's okay. Let's see what we've got. Now my problem says 4 equals 4. So because there's no x, just like with our previous example, because there's no x, this is going to be a special case. But also right here, 4 does equal 4. This right here is a true statement, and it's always true. So here, my solution, so we can write down my solution is all real numbers. That means any value you pick for x will be true. So your solution is all real numbers. You may find me notate this with a big capital R later on. I don't know if you've seen that yet or not. Okay, so take a minute to answer your final questions.